Hello, the topic is CPU scheduling algorithms and the course is the operating system. Now, in the last lecture, we have seen the basics of different scheduling algorithms and the basic definitions and the basic problems of FCFS, HJF, and the round robin. Now, today's agenda is we are going to review what we have learned in the last lecture. And then we are going to see the CPU and input output bus, CPU scheduling and CPU scheduling criteria with the different arrival times and different algorithms. And then finally the comparison of these scheduling algorithms. So in the last lecture, we have also seen the first come first serve, shortage of first and the round robin. We have seen the meaning of the scheduling, but we have solved the problems with the all the processes are arriving at the same time. Now, whatever the new points we are going to see in this lecture compared with to the previous lectures are, we are going to see or going to solve the problems with different arrival times that we have not seen in the previous lecture. In the previous lecture, what we have seen, we have solved the problems with all the processes arriving at the same time. So, new concept or the new point in this lecture is we are going to solve the problems when the different processes arrives at the different time. That is, the arrival time of the processes are different. Also, the second new point that we are going to see in this lecture that SJF can be acting as a preemptive as well as the non-preemptive scheduling algorithm. And in the last lecture, we have solved the problem of SJF with preemptive scheduling algorithm. Sorry, non-preemptive scheduling algorithm. But in this lecture, we are going to solve the problem of SJF with the preemptive scheduling algorithm. The FCFS is the non-preemptive and the round robin is what the preemptive schedule algorithm. And finally, we are going to conclude with which algorithm is the optimal. So scheduling is what the deciding the process, deciding the which process or the thread should apply or occupy the resource or the CPU disk. Then the what is the meaning of the CPU and the input output bus cycle? Now we are having the different processes to be executed and we are having the single CPU. So process execution consists of a cycle of CPU execution and the input output wait. Processes move back and forth between these two states. A process execution begins with the CPU burst and followed by the input output burst and then the another CPU burst and so on. So we are having the combination of input output bus and the CPU time or the CPU burst time. So as already we have seen this the meaning of the preemptive and the non-preemptive scheduling algorithm. Uh, we are having the first one is what the preemptive scheduling algorithm. In the preemptive scheduling algorithm, what we are having the processes can be removed from the CPU before the completion of the or CPU can be removed from the processes before the completion of the processes. But in case of non-preemptive scheduling algorithm, you are not allowed to remove the CPU from the process till the process is completed. So in the non-preemptive scheduling algorithm, you are not allowed to remove the CPU. In the preemptive scheduling algorithm, you are allowed to remove the CPU from the processes. Now the different scheduling criteria are there. So first one is what the CPU utilization. The CPU utilization should be or the CPU should be as busy as possible. And the next criteria is what the throughput. So throughput means what the number of processes that complete their execution per unit of time. The waiting time is what the amount of time a process has to wait in the ready queue. And we are having these formulas for the waiting time. Turnaround time is what the amount of time to execute a particular process, that is the finish time minus arrival time. Response time, it is what the amount of time it takes from when a request was submitted until the first response was produced and not the output. Now we are having the different optimization criteria. So CPU utilization should be maximum. Second criteria is the throughput should be maximum. Then the turnaround time should be minimum. Then the waiting time should be minimum. The response time should be minimum. Now we are having the different scheduling algorithms. So we are having the classification. So first two, that is the FCFS and shortage job come under the batch systems, while the round robin comes under the interactive systems. Now initially we will see the first come first serve algorithm details. So it is what the simplest scheduling algorithm. It is what the non-preemptive algorithm, as we have seen. The processes that request the CPU first will be allocated the CPU first. It is implemented in the first in first out queue. When the process enters in the ready queue, the process control block is linked to the tail of the queue. When the CPU is free, it is allocated to the process at the head of the queue. Now here there are some limitations of the first come first serve. FCFS favors the long processes as compared to the short one. The average waiting time is often quite long in case of first come first serve. Also, FCFS is the non-preemptive, so it is trouble for some time for the sharing of the processes. The another problem in the FCFS is what the called as the convoy effects. Now, convoy effect means what we are having the set of processes that needs the resources for very short time, but there is one process which holds the resource for the long time. So this blocks all the other processes, causing the pure utilization of the other resources in the system. So this is what the convoy effect because of what the FCFS algorithm. Now we are having the example for this FCFS algorithm. Uh, so we are having the three processes P1, P2, P3, and the corresponding burst time is the 24, 3, and 3. And these processes arrive at the in the sequence P1, P2, and P3. So initially P1 is arriving, so we are going to burst time required is 24. So we are going to allocate the 24 after completion of P1. The second process will get the CPU. Second process requires the burst time equal to 3. So 24 plus 3, 27. And the last process requires the 3 milliseconds or the 3 unit of time. So 27 plus 30 milliseconds equal to 30. So we are going to calculate the average waiting time, that is the waiting time of P1 is 0, waiting time of P2 is 24, waiting time of P3 is 27. So addition divided by the number of processes. So average waiting time is 17 milliseconds for FCFS example. Now in this case, we can also find the average, this average waiting time is 17. Now in the FCFS example, suppose that the processes arrive in the different order, the P2, P3 and P4, P1. Then the Gantt chart will be this one. So waiting time of P1 is 6 milliseconds, 6 milliseconds. Waiting time of P1, P2 is 0 milliseconds here. Waiting time of P3 is 3 milliseconds. So average waiting time is 3 milliseconds. So what we can conclude, if the short processes arrive initially, then the average waiting time is going to reduce. Now we are having this example that we have not seen in the previous lecture. What we have added in this example is for the arrival time for the different processes. In the previous two examples, all the processes are arriving at the same time. But in this case, the different processes are arriving at the different time. So in this case, initially arrival time of the P1 is 0. So P1 is allocated the CPU for the 24 milliseconds of time. Then the arrival time of the P2 is 3 milliseconds or the 3 unit at time. So then the 24 plus 3, 27, and finally what the P3, the 27 plus the 4, so 31. So average waiting time is what is 0 plus 21 plus 23 divided by 3. So here we have to consider the arrival time of the process while drawing the chart that we have not seen in the previous lecture. So we are having the problem as an work. So these are the processes, these are the arrival times, and these are the burst times of the respective process. You have to find out the average waiting time and the average turnaround time. Now the second is what the HJF and SRTF. SRTF means shortest remaining time for scheduling. When the CPU is available, it is assigned to the process that has the smallest next CPU burst in case of HJF. If the two processes have the same length CPU time required, the FCFS scheduling algorithm is used. Now, as we have seen, the HJF can be non-preemptive and the HJF can be preemptive. When it is non-preemptive, it is only the HJF. But when it is preemptive, we call this as what the shortest remaining time first. So we are having the example, the different processes, four processes, the burst time required for these processes and the order in which they arrive, but in this case arrival time is same. So we have solved this problem in the previous lecture, in which case what? Arrival time of all the processes is the same. So already we are knowing this process. So burst time for the P4 is minimum. So third, 0 to 3. Then the burst time of the next process P1 is required is the minimum compared with the other processes. So P1 is executed, next P3 will be executed, and finally what the P2 will be executed. So we are having the waiting time of different processes P4 0, P1 3, P3 9, and the P2 16. So total running time is what the 24, and average waiting time is what this number of addition of this waiting time divided by the number of processes. Now we are having the new problem that is we have not considered in the previous lecture. So here what the two processes are arriving at the different time. So arrival time of the two processes is different. So P1 is arriving at 0 time and P2 is arriving at 2. So duration or the burst time required for this process is 10 and 2. So at time 0 P1 process is available to time quantum of the 2 after 2 milliseconds the process P2 arrives. So after 2 the process CPU will be allocated to the P2 and P2 requires the 2 unit of the time, and then the remaining time is allocated toward the P1. So in this case what we have the P2 requires the minimum time, but it is not arrived at the time 0. So we have allocated the CPU to the P1 initially. Now when the P1 is in the execution, and but at the time 2 the P2 arrives, so remaining time of the P1 is 8 milliseconds, but the execution time required for the P2 is 2. So 2 is less than the 8. So we allocated the CPU to the P2, and after completion of P2 the remaining time 8 milliseconds is allocated toward the P1. So average waiting time is what the 0 plus 2 divided by number of processes is 2. So this is the new concept that different processes are having the different arrival time that we have not seen in the previous case. Now the next is what the problems for solving. We are having the different processes P1, P2, P3, P4, and the arrival time is different and corresponding burst time is given to you. You have to find the average waiting time and average turnaround time by considering the arrival time of the different processes. So this is the first example. This is the second example you have to solve. Then the third example having the different arrival times using what the both the cases of what HJF and the SRTF, shortest remaining time first. Now the third case is what the round robin case. Each process here gets that small quantum time. After that time quantum is over, the CPU will be allotted to the next process. But here if the time quantum is large one, it will be acting as first in first out. If the time quantum is small, Q must be large with respect to the context switch. Otherwise the overhead will occur. So here is the example of the processes P1, P2, P3, P4 and the corresponding burst time. Time quantum is 20 and initially the time quantum will be allocated to all the processes in the sequence P1, P2, P3, P4. Then what after completion of the first run again the P1, but the P2 is now completed as it requires 70 milliseconds. Then in the same sequence P1, P2, P3, P4, then finally what the P1, P3 and the P4. So we can calculate this average waiting time and the average turnaround time as like this. Now the new concept that we have not considered here is what if the arrival time is what the different for the different processes. So P1 is arriving at the 0 time milliseconds. So and time quantum given is the 1 millisecond. So in this case P3 requires the minimum time, but P2 is arriving at the 0 milliseconds. At that time P3 is not arrived. So initially processor will be allocated to the P1 and just like follow the same process to solve the problem. So we can conclude from this that by solving the different problems, HJF is the optimal as average turnaround time and average waiting time is minimum for the given set of processes and for the respective burst time. So conclusion is what by solving the different problems, HJF is the optimal algorithm for the different scheduling problems. Thank you.